So good evening all. Welcome everyone to the 7th session of Rise Up. Today we are having our friend Rithish who would be doing his presentation on computer programming execution today. He is studying in class 7th at Indian school in Muscat. To talk about him, I would say that he is very good in drumming, right? I saw him in Multiverse and even though we were in opposite teams, I thought he was a bit young. He was in my age or a bit younger than me, but I was so shocked to hear that he was just only 7th, as he talked very maturely, very silently, calm, not like me. Then also we became our main rivalry in the debate in Rise Up. He interacted very well during all these programs, and became a much good friend for me. Then also in the studying and computing, I think he's very better than me, because even though I'm in 10th, he knew much more than me. That are many topics that I hadn't heard before. Now, so I think that this session will be much interesting and very informative. So now I'm handing over to Rithish, who will start the debate, start his presentation.
Yeah. Thank you, Avinash, for your very nice introduction. I would like to thank Satish sir and my teachers who joined right now. Satish sir is like a very important person to me because he has given me a very nice opportunity to present in this Rise Up session. So I really like to thank him, and thank you all for joining. Okay, I would like to begin this session by asking you all a question. Have you, when you're using a computer or any device which gives some information like a computer or something, have you all wondered how this computer does these different tasks? Like before and all in history, we know that computers are just like calculating machines. They are calculators. Even when Charles Babbage first he gave his plan, it was a calculating machine. But then suddenly a computer is like with a keyboard, with a screen. Have you all wondered like how this is happening? How a computer really does all these functions and tasks? Anyone? Megha, you? What about you?
Not really sure.
Yeah, I know. I know. Because now many programmers know to code, but they don't really know how a program gets executed. So that is what I would like to talk about today. This is actually a bit complex. It's actually a very complex topic. This execution of programs. The main thing I would recommend is just understanding how the computer gets to know the binary numbers first. So binaries are ones and zeros. They are the main the building blocks for programming and how a program is understood by a computer. So what you will learn in my presentation is what are programs. To know about how a computer executes a program, you will need to know about what are programs like Python, Java, and all. And I will be adding a few points about these programs too, like why we use Java more than Python, why is Java still there if Python is more easy and all. But we have to first understand what are programs to get to know how a computer executes a program. And we, for executing a program, we have like given a set of parts of a computer that help in program execution. So when these parts come together, then finally they start executing a program, they start running a program. And how a program reads and executes the program by combining all these parts with the help of all these parts of the computer. And there is also one function which is known as a compiler that we will go ahead look up later. And how a computer executes a program with internet. For example, now when we are downloading a file from internet, we might have seen in Google or bottom, you might see receiving data from this link or something. So how do we get all that thing? And when we enter Google or we go to our classroom and all, then how do we get to know about, how does the computer get to know about this is the classroom? It's slightly more complicated, but I'll be explaining the base of how this computer does this with the help of internet. So first, what are programs? Why do we use languages like English, Hindi, and French, or etc.? Can anyone tell me? We can be more interactive, I would suggest.
Yes, Rithish. communicate.
To communicate.
To communicate. Yeah, that's exactly the main point. So we have different languages. When we're born, certain thing like I'm a Tamilian, so I talk Tamil and all. And maybe Avinash, you are a Malayali, so you talk in Malayalam. But that doesn't mean like we are using all these languages for communication for one base purpose, which is communication. The same way, even if we have different programming languages, we use all these programming languages for one basic thing. So we'll look on that. So a program is the definition for the computer. It defines each and everything that is a computer, what a computer is doing, which tells the computer what to do. It is a set of instructions which are executed by the computer to perform different tasks. So whenever I write maybe a program in Python, Java, something, the computer understands it, then only starts to execute this program. So programs are like set of instructions. It is a set of instructions which are executed by the computer to perform different tasks. It is also used to develop applications. So these programs, if you know how to code, then you will develop application, web designing and all. So you can use to develop applications, and that is also run by the computer. So after this presentation, after my session of today, Raisa, you will know like how this happens with why we are using this program to develop applications. And the fundamentals of modern computing are developed by programs. Without programs, like we don't have anything. We don't have what we are displaying in the screen or anything. So programs are very important. And in short, we can say it's a communication language to each other with like how we communicate with each other with different languages. A program which is also called a computing language. So when you say this is a computer program, so Python is a computer program, the same way it is also a computer language or something. So a language means communication, so a computing language which is used for communication. So programs are used for communication. So when we write a program, it is used for communication between us and the computers. And these programs, when we run an application, it is used on online application, maybe it is used for connecting different computers. So now we will learn about the main parts of the computer. So I'll just give the main important parts of the computer. So the central processing unit, which is also called as a CPU. I'm sure you all know this, but it's not only the big boxes you see. It is also the small chip, which is like in the motherboard. So motherboard is like the main board where all the components of the computer, like they are placed. So this CPU is placed in the motherboard of the computer. And RAM is also called memory. So many times they confuse between memory and storage. So memory is like the common term which is used for RAM, but nowadays we think it's like storage, but it is not. So RAM is we can call it as memory. Storage storage is the disks or the drives. For example, hard disk drive and solid state drive, like that. ROM is read-only memory, so it is only used for booting time. Booting time in the sense when you switch on the computer and all. So the question is, how does all these parts help? The main parts it is. There are furthermore parts, but then these are the main parts which help in the execution of programs by for a computer. So how does all this help? The computer only understands zeros and ones. So zeros and ones are binary numbers. So zeros and ones are binary numbers. So the computer only understands the binary code, or binary code can also be called as machine code. So 0 is equal to off and 1 is equal to on. You will understand what I'm trying to tell by 0 is equal to off and 1 is equal to on. The computer functions with on and off command. So for example, if I have an apple, or if I have 6 or 7 apples in my hand, and I ask, hey, Avinash, can you hold at least 3 for me? So Avinash might think, should I hold for him or I shouldn't? So these are like the basic type of structure of a computer. Yes or no, like on and off commands. So, but how are these on and off commands executing such complex tasks like Zoom presentation? Now I'm presenting in Zoom, and how is it doing so? That is what we will be learning today. So ROM is read-only memory. It has permanently stored files that give the parts of the computer instructions mainly during booting time. It also gives it instructions after booting time, but very little. But mainly its main function is when you press the start button of the computer or any device, it this ROM which is stored will give information to the CPU, and it'll start. It is mainly used for this thing, booting time. It has all the stores, the system files required to during the booting time of the computer. The ROM is inserted in the main board, also called the motherboard. So the main board, which is the green color board where you see all the tests like PAK or something, the third terminal or the fourth terminal, and then you can also see the chips and all the things over there. That is called a motherboard, okay, where all the components are placed, which is inside the computer. The external parts are like they're used for giving the command for the inside of the computer, for example the keyboard. So the internals of the computer are like situated in the motherboard, or and the ROM is like not only inserted in the motherboard, it is in the chip called BIOS chip. So BIOS, the full form of BIOS is basic input and output system. And this BIOS chip, it has ROM, so it mainly instructs the CPU. It also, gives some information to the RAM and all those. But the main task of this is to instruct the CPU during the booting time. So now we'll learn about RAM. RAM is random access memory. I'm sure most of you might have known it, but even though if you don't know, it's fine. So RAM is random access memory, and it stores the main temporary knowledge and files that are important and necessary for the computer. For example, if I want to keep a meeting with Clemmy today, for example, then and I am really busy today, so I might keep an alarm or something for just for today, and maybe at 4 o'clock I'll keep a meeting with Clemmy, and then I'll keep an alarm, and that alarm right only that day, only for that day, comes at 4 o'clock. So that is why it is like called the temporary memory, because after meeting with Clemmy I might delete it. That's it, it's gone, I won't use it again. And note, it is not permanent, because once the device is shut down, once your device like computer or mobile is shut down or restarted, the memory and RAM will permanently delete. So that is why when you see your computer lagging, you will think, oh, what is happening, and then someone might tell you can just switch on and restart your computer or something. That is because of this main reason. Every application running in your computer will use this RAM to store the temporary files it needs for the running time, for the execution time of the application. So it will store all the files which it needs temporarily in this RAM. So in this image you can see it has like 8 chips, and in this only 4. So have you ever heard of like different RAM capacity? For example, 8 GB RAM, 4 GB RAM, and in this one I guess it is 16 GB RAM. So this is how RAM works. And you'll learn about these chips. I guess I'll explain it later. So what many people, sometimes they get confused. What is the difference between ROM and RAM? What is the difference between read-only memory and random access memory? But the important thing is these two parts, RAM, random access memory, and ROM, with read-only memory, are both present in a computer. So these both are needed to function a computer. They are also like the brain of the computer, not only the CPU as we have now. So now let's try to differentiate between RAM and ROM. The role played by RAM is also called random access memory, and is a specific type of data storage. So it is a specific type of data storage, and it allows data to be accessed in random order. Here it is random order because you do multitasking in your computer or any device, and while doing multitasking, this application stores only its necessary files in this RAM. So it'll be in jumbled order. It won't be like neatly assembled. So in the random order, which means specific information can be found quickly for the application. And while ROM is or read-only memory stores the basic instructions for what needs to happen when your computer is switched on or during booting time, like I have explained. So the function of the RAM is the CPU, which we'll be covering right now soon, is where it goes to the RAM to fetch the instructions it needs to execute for the particular application. So it goes to the CPU and it fetches the instructions and data that is needed to for the application to work on. So RAM gets its contents by loading them from the storage. So what happens is these chips here, they are also like this ROM, but they are different. They are different in the sense they are not like ROM. They do the same activities like ROM, but it is totally different. This is basic input and output system. So many chips like this will be placed in this RAM chip over here, and this RAM chip will temporarily it will store its files in the storage in the drives like hard disk drive or solid state drive, which we'll also be covering right now. So RAM is also temporary storage for data for programs that are running, allowing the programs to work faster. Because every time the CPU can't keep running, the CPU has you might have heard maybe Intel Core i3 or i5. That is because different cores are there for the CPU to run, and the CPU can't always be doing this task. So it stores the temporary data of these programs in the RAM, so it works faster. It's more efficient, right? And the ROM, it contains the basic code to get the computer started during the booting time. So whenever you install the updates, it goes to the ROM and then it stores. But one important thing is you can never change the data which is there in ROM. It will be stored in the history of the BIOS chip, or it will get deleted and new updates will start flooding in the BIOS chip, which is where the ROM is placed. Okay, the ROM is normally stored on the BIOS chip in the motherboard. Sometimes even there's like a particular device for ROM storage, but many computers nowadays they usually use ROM. So this BIOS chip in the motherboard, the information stored in the ROM is often difficult to change. That is because even if you run the program as an administrator, you can never change the windows, the files important for the booting time. And the information stored in the ROM is often difficult to change, and the data is not lost when the computer is powered down. So I guess I mentioned it before in the ROM slide. I've given it's a permanent data and it can never be changed. So this permanent data can never be changed and it'll always be there. So now let's learn about storage. So the storage is one of the most critical part of the computer. I've given the most critical part. Every part of the computer is the most integral part of the computer. But without storage, the whole computer won't work. Like the CPU, even if you remove the CPU, some programs will work, because nowadays we are changing the CPU to more alternatives, so the work of the CPU can be reduced. But even without the CPU, it will slightly work, like the booting time. But the storage, if it's not there, then it will completely, it's gone. If the disk of this hard disk drive over here, if it is gone, then you need to just replace it. You can never change it. And the storage is one of the most critical part of the computer, and it handles the system files, trajectory, and operating files. So system files, in the sense, if you go to the folder and you go to this PC or menu over there, you can see there's this thing called Windows, trajectory and all, where all the Windows or the operating files, for example, Mac OS, Linux, or Windows, all these files will be stored in this storage, and you need to run it as an administrator or privilege to make any changes for this. It handles it also has space, as you all know, to save the files. Every time you're doing maybe a Word document or something, you store it in, it goes and stores it in the storage. So the process by RAM and ROM are sometimes stored. So for example, this happens to me many times in my old computer. The computer totally crashes, and sometimes the memory it doesn't get booted properly. So every time every time this happens, there is this thing called system restore point. So in system restore point, when you go and it stores all the information of one point or one particular day, and it stores as a trajectory file. And then when you do the system restore, the previous version of, like, today I have my files in this computer stored, but tomorrow maybe the booting didn't start properly and the files get they don't come up properly. So what I will do is I will do system restore. So I guess this is a very important point, because this might happen to your computer also. So this is very important. So you can go to the system restore point and restore the previous version or the using time of your computer. The CPU before shutting down or restarting creates a restore point for the computer, which will temporarily store it in the storage. So after some days, after you download some new files or something again, it will delete the previous system restore point and create one new. Or in some computers, it keeps it because maybe it needs more suffocating for maybe the update history or something. It stores it in the restore point. So the two different booting devices are used for the storage. So over here, if you see the Samsung one, this is called a solid state drive. You can see it is very compact, no, compared to the hard disk drive. It is very thick because it consists of disk rotating in this arm. Okay, it is where all the information is stored, and this is the hard disk drive. So I guess if we have time, I will also explain the storage between this thing, hard disk drive, and the solid state drive. So either hard disk drive is used or solid state drive. But one important thing is, in some computers, both this solid state drive and hard disk drive will be used, because I guess some new version of the computer you can customize it, because a state drive might be used for the information for the booting time also, to provide more faster thing for the application or something, and HDD will be used for this thing task for storing all the files you want. Okay, so I'll tell you something. If you have $156 or something like that, and you buy a hard disk drive or a solid state drive, the solid state drive will be very expensive, and the hard disk drive will be very cheap. For example, if I have $200, I might get something like 500 and 256 GB of SSD for storage. But with that same amount, I can get solid in hard disk drive, I can get about 4 TB of storage. That's totally I guess 3 or 4 times more storage than solid state drive. But then solid state drive is more faster than hard disk drive, because every time you start booting the computer, this hard disk drive will start rotating, and then the information is totally over there. So this information will slowly start to come. Well, this solid state drive, it doesn't have any moving parts like this. Moving parts in the sense this the arm and all. It'll work with the basis of electric currents. Okay, so every time the electric current passes through the solid state drive, it'll give the system files immediately. It'll happen. So solid state drive is more faster. Now we'll come to the CPU. CPU, as you all might have learned, is the central processing unit. In your school classes, you might have learned this is the central processing unit for the computer. So the CPU, with the help of RAM, ROM, and storage, RAM has the the temporary files for the applications. ROM has the booting files, and the storage has the files you want to run later, or the saved files you have. So, the storage in the sense HDD and SSD, or HDD or SSD, fetches and decodes and executes every operation of the computer. So, each and every part of this computer is programmed and coded. So this CPU is what executes it, executes each and every operation of the computer. So it without CPU you can't actually execute the program, but then you might be able to get the electric current signals in the computer, so you can replace that chip. That is what I was trying to tell earlier. Is it the most important or the most integral part of a computer, like we have all learned, like without the CPU the electric signal can't be passed or something? Well, not really, because nowadays in gaming laptops they are trying to change everything, or even in business laptops and personal use, they're trying to change the work of the CPU by different parts. And the CPU mainly helps in executing a program, which is the main part of the CPU. And many other components are also necessary for helping the CPU. So without the RAM or ROM, it won't work, and especially without the storage, it's not going to work. So the CPU is more of an executing device, so it only mainly helps in executing the program. So the CPU is made of transistors and threads. Threads in the sense, the small conducting things which will be there in the CPU. The images here. See, these and all are called threads, and over here it is the transistors. So The material, used mainly for this transistors, CPU, this threads and all is gold. That is because gold, as I guess you might have learned in your school, gold is the best conductor of electricity. So the best conductor of electricity should be mainly in the CPU. And even in budget laptops or any budget device, it'll mainly be stored in the mainly be you gold will mainly be used. That is why it extends, and even in gaming laptops, when you search for, even it'll be might be Intel Core i9 or something. So over there, it'll be expensive because CPU performance requires more threads and more transistors to work more efficiently in gaming laptops. So now let's look what transistors are. So transistors are simply electricity gates. So these devices are mainly electricity gates. I would really recommend you to go to Leon Sir's class course recordings on the anatomy of computer, because he would have really explained RAM and all. So even in he would have really explained RAM. So I would really appreciate if you would go through that. And the electric gates are like, for example, and, or, SOR, NOR, and NAND. For example, so these electric gates are the main things that will understand the program, which we will see when we come to the compiler part. And that electricity pass through the circuit which execute the result. So for example, if it goes through AND gate, it will go to another gate, and these both gate will combine, or gate, not this one, the next one, maybe like that. So that is how the computer works. And this is a very important, these transistors. For example, the screen you are watching can give out different colors. The screen has pixels. This is not actually the best way to tell how this screen or the monitor works, because it has a bit more complex things which you will have to see. But then this is the basic principle of how this screen is shown, or how the computer how this transistors helps in giving electricity and executing the task. The screen has pixels containing 4 colors, RGB colors: red, green, and blue. White is mainly used for brightness. um, Given out by called RGB. These RGB colors are given out by these gates. So these gates give the electricity sufficient for these pixels to give out the colors. And you may not understand now, but you will later. Yes, like when we come to the binary part of how these transmitters help in binary code, we will get to know it more better. So they work when transistors receive the electric flow. This flow is sent by the ROM and RAM for the CPU. So mainly the RAM, the ROM during the booting time, and the RAM. So when it starts executing, the CPU goes to the storage. It brings the files needed, and then it says, "Hey RAM, I can't handle all these files. So can you please handle this for me?" So this RAM keeps all these files, and whenever the CPU needs, it'll go to the RAM. It'll fetch the details, and then slowly, it'll start decoding, and that's how this computer works. And mainly the RAM. Leon sir explained how this RAM generates electricity, but this is how it goes. But the CPU also helps in giving this gates and all. So how can you store data and electricity? We charge it, we do everything, and these transistors give out to the electric gates. But how do you store this in electricity? This is the main doubt in which you can clarify how this program works. So these transistors, as they transist electricity to the gates, they give these electricity charges to the gates. It acts as binary numbers, more of representation. So the image is here. Every time it receives electricity, when the transistor is received power by the CPU, it indicates binary number 1. So binary number 1 is equal binary number 1. Okay. Binary number 1, as we learned in the second slide, it is equal to on. So every time this transistor receives this electric data, it is on, or else it is off. That is how these transistors mainly help in converting this electric data to binary numbers, which is the machine code. So when the transistor receives the electricity, it represents 1 or on, and electricity is converted to data. So 1 is equal to on and 0. So this is how the transistors are there. To know more about how these transistors work, They are like, there are, I guess, eight transistors, and they are raised to the power this thing. So one transistor is equal to one whole transistor, and they perform one set of execution tasks. So this is how a computer, does it. And electricity is converted to data. This helps the computer to perform many tasks, as 1 and 0, which are binary numbers, are the only numbers understood by the computer. So binary numbers are used in this way to store data with the help of electricity. This is how we can use electricity to store data. So now, what if I write a program? I will be using, an example. For example, if I write a Python code, say, I give a variable and I store a value in it, maybe 3, and then I'll say now the number is, if number is greater than 0, then it is a positive number, or it is 0. Else, it is a negative number. So this is a code if I write, what will happen to this? We only know the executing part. What will happen to this? If it is maybe 4, then it is the computer will print a positive or 0. Or if it is -1 or something, then the computer will print negative number. So, but how does this work? Then when you run the program, the Python code, the data will be stored in the temporary memory. So this data, which is stored, this data, which is given by the application, will go to the RAM. It'll be stored in the RAM, and the temporary memory, that is the RAM, will store this, and some tasks will take place. So the main task which will take place is the binary conversion. This is how this is the most important part, in which the program converts this source code, which the code which we are writing, or the assembly language, for example, Python, the low level language, to binary. So when the RAM temporarily stores the program for executing or running, it is in the text format. Text format in the sense, over here I have given this in text format. I haven't coded it in binary 0, 1 or 0, 0, 1 or something. So how does the computer, which only understands binary codes 1 and 0, run or execute this program? The program, after it is saved temporarily, it is converted into binary codes. Then how is it converted into binary codes? So for example, I'll take another, the code which can be understood by humans, that is, for example, this num is equal to 3, this set of code, or hello world. It is called source code because that is understood and written by humans. And the language which is used is called assembly language. It is called assembly language because it is the low level language written by humans. So we first write this language, then only it gets executed. So it is the lowest level of programming. Now this language is converted to binary, mainly binary and hexadecimal values. I will recommend you to forget these hexadecimal values. Just forget this hexadecimal. But in case, hexadecimal values are 16 base numbers. Okay. So these binary numbers 0 and 1 are like converted from this text format, are converted to binary numbers 0 and 1. Now we'll come to the compiler. The compiler is a place in the computer where assembly languages or source code gets converted to binary numbers. Actually, this compiler is not like a chip as you have seen in the RAM or something. It is more of a program, and this program converts the assembly languages like the Python codes or Java Python codes or C++ codes, class files or py files to binary numbers. The compiler takes the file code and compiles it. But how does the compiler do this? This is the main question for how the understanding how it runs the program. So how does this compiler change a code to binary? So the compiler goes through different stages of analysis. For example, the syntactic analysis. The syntactic analysis is actually analysis where the function and definition, the code I have written, the number is equal to 3, that is like a function code. And then this definition of that num is stored. So it relates each and everything, and it is made sense to the compiler. The compiler cannot directly understand the code, right? Because it is in assembly language, and it is also a machine, it is programmed by a machine. Then how does it understand the code of the assembly language we have written? It is mainly understood because it replaces the code, the text code, to binary numbers, and it tries to relate each and every code replaces the code with the code it knows, and it relates, and it goes through different stages of analysis before coming to the conclusion, and then it is converted to binary code or the machine code. One thing I would like to tell you is, if the compiler directly converts the code to binary, then it is called assembler. You will know why I mentioned this point when we come to the networking of the computer. So this over here is a class file, which is a C program. It goes to the compiler, and then it becomes the machine code, which is the executable code of a computer. Now, how does the binary code gets executed? How does this binary code get executed? The binary code is then fetched by the CPU, as mentioned before when we discussed about the CPU, and then it decodes the binary code. So the fetch, decode, and all those stages which are done by the CPU are now being done again. Like, it goes to the, the compiler gives these instructions to the CPU. It fetches the data, and it decodes then the binary code or the machine code. So the CPU will understand the code as the compiler converted the source code to binary. So over here, the compiler, as we have learned, it converts it to binary, right? Machine code. And this is a code which is understood by each and every part of the computer, which is the machine code 0 and 1. So this CPU will understand the code as the compiler converted the source code to binary. Now, how will the CPU execute the code? How it fetches the data, it decodes, but how will it execute the code? So the compiler, it's a very intelligent thing. It gives a set of instructions. For example, today if I have to present, then my brain gives me an instruction that, oh, you have to do this, you have to present a PPT. So you start making a PPT. The same way this compiler would have given the CPU a set of instruction the CPU has to follow. So this CPU fetches this instruction, it decodes it, and then it executes it by in the machine code, and the CPU distributes the electrical signal from the CPU sends the electrical signal to the various parts of the computer, as mentioned in the machine code. Machine code, as mentioned in the machine code, in the sense the machine code which is translate the assembly language of the source code translated by the computer, so that it will be converted to binary. So that machine code, the whole computer works together to execute the final task. For example, the RAM, the CPU will tell, hey RAM, hold this file for me. Then the CPU will slowly start executing these files, and then these files, if you want to save, it'll go to the storage, it'll store, and this will be repeating this process from the transistors, from the RAM. It'll keep on repeating to till the final execution, with the help of transistors also. Yes. So the CPU sends the electrical signal to the transistors, because they are the gates, right? So that is how the transistors, and 0 1 1 0, that is how the computer executes. So this transistor, as mentioned in the transistor slide, if it gets the electrical signal, then it is 1, and if it is true, it is 1, and if it is false, it is if it is 0. So 1 is equal to on and 0 is equal to out. This is the main basis in which the computer gets to know yes or no. Like Avinash, like I gave that example of Avinash storing, helping me with the oranges. So these transistors, to make it easy, transistors are mainly, like, if you can relate it to the human body, then it'll be the cells of our human body, because these cells are like very important for us to work, right? For us, it's a building component of our body, right? The same way this transistors, it builds, and it is a main part of the computer for execution of these programs. So now, how does a computer execute with the internet? A very complex thing indeed, but then I will simplify it in this presentation. So how will this computer execute with the help of internet? Yeah, this is slightly different and complicated, but the main thing is, you have to understand, when this transistor receive 1, it is on, and if it doesn't receive any electrical signal, it is off. So yes or no, and the CPU gives the data like this, yes or no, and then it'll get executed. But that's the same basis, but it is slightly different. So there is this thing called a Wi-Fi receiver, network receiver chip in your computer. It's a chip which receives the signal sent from the modem with the help of router. So I would really recommend you to the INSER's computer networking course recordings, because he detailedly explained this router modem and all. So this router it receives and sends the data, and this modem is consisting of a modem and a router. So the receiver chip receives signal from the modem, which in fact receives the command from the internet service provider, which is ISP. So this ISP, this modem requests the ISP signal data. It goes to the satellite. The satellite will connect to different parts of the computers. So this is how this whole structure of cloud is created. It is stored like this. Cloud is a bit more different, but this is how we can receive and send data, and we are communicating to each other through Zoom or Google Meet or something. And so this modem, which in fact receives the command from the internet service provider. So now, how does this network signal get executed? So now I will, if you can, just check outside your window, or you might later. You will find maybe in a few radius in your eyesight or something. You might find this type of tower. You might find this type of tower. So this tower is what is like the communication device between the internet service provider and the modem. So the network tower receives the data from the internet service provider and sends the signal to the modem, or it receives the request of giving the data from the modem and sends it to the internet service provider. So there are like not only one tower is used. In a few, after some distance, another tower is there. So this is how, tower after tower, like this tower sends the signal to the other tower, or it directly sends it if it's near the internet service provider. The modem spreads the signal to the connected devices. Now the question is, how can I connect a particular device? For example, if I connect my laptop, how do I receive that information from the modem? Because then, might be my her other family members might be using a computer or something like that. So how does, the connected device receive the signal correctly? That is because each computer has an identity code called MAC address. So this MAC address is what differentiates between each device you're using. So the computer sends the request to the modem, and the modem identifies the MAC address. Then it sends then it sends it to the internet service provider. The internet service provider answers, and then it receives the data signal and again sends it to the requested computer. Now this signal is used to execute. So execute task as the signal contains the binary information which is given out by the server of the particular website. So every website we have now is stored in the cloud, and this cloud has the server details of this. So this requested server will go to the cloud, and then the internet service provider will find the correct address. This topic is actually a bit more complex because it has even more tasks going on, but like this is the main thing which is actually happening. The Wi-Fi is also the binary information which is given out by the server of the particular website. So after we receive the binary information, the CPU tells the RAM store this and give it to the compiler. So the compiler takes this and again gives it if it is in the source code, or sometimes as I've mentioned before in the compiler slide, if it directly converts the binary and sends it to the CPU, then it is called an assembler. So if the server directly sends the binary code, then it is the compiler becomes an assembler, and which is given out by the server of the particular website. The Wi-Fi receiver chip the computer, after it receives the source code, transfers the source code of the server to the assembler. So what happens is the CPU after it receives the source code, transfers the source code of the server to the CPU. So the compiler, it compiles everything and then it sends it to the CPU. And again, it's a cycle. The CPU will again send it to the electric signals to the transistors. The transistor will be 1 or 0. But to really understand how the transistors work, we need to know about the details of the architecture of the motherboard. So Now, if I want to differentiate between SSD and HDD, this is a bonus I wanted to add. So now, what is the difference between HDD and SSD? Actually, to be honest, they are completely different. They are not. It's like comparing. They are not different in the sense they are. It's like comparing green apples to red apples. It is your personal choice. But then for me, I like green apples, and green apples are more tangy. That means you can maybe green apple for me is SSD. The same way for the same way we can't actually differentiate between compare HDD and SSD. But to be general, what is the difference between SSD and HDD? So solid state drive, SSD is solid state drive, and HDD is hard disk drive. So SSD contains the electrical parts. Example, IC. This and all you don't need to learn because they are a bit more complex. We need to go in depth to differentiate between these two, but generally they are the same. And HDD contains of moving mechanical parts like this disc or the arm. And SSD is expensive, like I've given, like I said before. So if you want to buy an SSD or an SSD for $250, maybe you'll get 256 gigabytes of storage. But the same price you might use it, then you can get at least 4 TB of HDD. So HDD is more inexpensive, and it is also the materials are not like too complex to jam like this SSD over here. So it is more freely and it is more freely moving parts over there. So SSD is available in compact sizes and is relatively fast. So my SSD over here, this is like about the size of this paper over here. But this HDD might be the size of this whole box. So that is the difference between this. So for portability, you might need to use SSD, and HDD is like it's not commonly used nowadays by really good companies. And HDD is comparatively slower than SDD because of the moving parts. The disk needs to start moving after the CPU receives the information about the when you press the start button, it goes to the CPU. The CPU goes to the ROM. The ROM gives the instruction, and the storage needs to again go to the Windows trajectory to get the Windows file started. So all this will happen, so that is why HDD is more slower. And that is it for today. But I would like to tell one thing. This transistor over here, um, the transistors, right? Before and all, it was completely different. This transistor has gone through many stages of changes. At first, there was nothing like a transistor, but then there is this thing called in history we used to use vacuum tubes. So this vacuum tubes, if it has air, then it is on. If it doesn't have air, then it is off. But to be so there are like we have come a long way from big computer box like in the size of a cupboard to just a 13-inch or 11-inch laptop nowadays. And these devices, and one more thing is, if this is not only used for computer, any device like a mobile or an iPad or something like that also uses the same basis of executing a program, but some parts might be different. And that's it for today. And I would like to tell one more thing. If you know one more thing is many computers use different architectural systems. So every time you go and see any other thing, any other explanation for computers, many many companies nowadays use different architecture. So it'll totally be different. So when you try to understand more about this computer and you try to search videos or something, it'll be completely different. But I have in today's presentation, I've mentioned like the main parts of the computer which I like use for executing the program. And that is it for today. I would like to share, or I wanted to share all this information about how computer executes a program with you. And that's it. Thank you.
Rithish, it was awesome. Today I haven't heard this much thing from a student right now. Only I know teachers would say like this explaining everything, but I haven't heard a student rocking of the classroom, right? You were like that. No words. Do
Thank you.
anyone have doubts? Oh, do anyone have doubts? No? Then I would ask you something like, do all the mobile phones use the transistors, so it's only a part of computer?
Sorry, can you repeat it?
Transistors.
Mobile phones, no,
Do all these smartphones?
every device
Yeah.
which is nowadays modern, they use this very small transistors, and they do use every electronic device nowadays mainly use transistors too, because they also control the, sometimes in some devices they also control the flow of electricity. So this transistor is mainly used in all electronic devices nowadays.
Thank you. Others, any doubts? You could ask openly, right? No fear.
Yeah, I have a doubt.
Yeah.
Will the performance of the software, if it's differ from if it's STD or in HDD?
Yeah, sure. Yeah, that's a really good question, because I forgot to mention that. So the difference of performance will be like SSD is faster than HDD. Every time, if you're going through a PowerPoint, the HDD will keep rotating until the ARM finds the correct program, the correct file. But while SSD, it is just electrical signal. Okay, it doesn't have any moving parts. So this SSD will immediately give the electrical signals. So for sure there'll be a difference even in the booting time and even in the performance, if you have difference, if you use SSD or HDD.
Okay, thank you.
Is there any questions left? If no, then I would like to ask Ritish's friends and teachers, how was his presentation, right? Would you expected that he will give such a good class on this topic? Yeah. Teacher, ma'am, you could also tell about his. Snigdha, ma'am.
Excellent class. Excellent class.
Yes, ma'am.
Excellent presentation. Very nice, Rithish.
Thank you, ma'am.
A student of class 7 is presenting in such a nice way, and it is very, very informative. And the explanation, the way you explained is also very good. Excellent work.
Thank you,
You are
ma'am.
class 7, right? Class 7.
Yes,
Class
yes,
7. Yes. I don't know, some other teachers are there. They may also reply. I don't know. Any other teachers are there?
Yes, ma'am. I'm Mrs. Snigdha from
Okay,
middle
okay.
section. Yes, I taught Rithish actually last year. So I know him very well from the beginning itself. Last year he was in 6th standard, and he is really very, very inquisitive and totally in positive sense. It is. And this is the reflection, the way today he explained, extremely, really very nice it is.
Thank you, ma'am.
Yeah, friends come up, right? Your friends haven't came up. Tell,
Rithish, can I ask you one thing?
Yes, ma'am.
Rithish, yes. Rithish, all these informations you learned from your computer class, or you learned your own, or someone helped you? Tell me.
Ma'am, actually, no one helped me. My parents didn't help me. So there was this session by Leon sir and Hussain sir. So computer networking and anatomy of a computer. He taught us about how a RAM executes and how the anatomy of a computer. And I asked him a doubt how this computer is executing such programs. And he told to learn that you need to learn different parts of a computer. So that day I did some research and I found out like there are these different parts of computer and this is how it executes a program.
Yes, very good. So your self research work is there behind this presentation, right?
Yes, ma'am.
Okay, good, good.
Yeah, you could talk about him, yeah. How was he in class? Was he different? Was he was giving like classes to others, or he remained silent? His friends, I'm asking his friends. You could tell about him.
Who is there? Rithish, friend or a teacher? Teacher is there. Friends, I don't know anyone is there.
Shaurya is there. Last year,
Yes,
Shaurya, I
ma'am.
know Shaurya was there with
Yes,
Rithish.
ma'am.
Yeah.
Yes.
Yes, ma'am.
Shaurya, tell.
And Jyotish.
Yes, ma'am.
Jyotish
Ma'am,
is also there. Yeah.
ma'am is very attentive. He's very nice. He's very smart. And ma'am is very friendly. He's the best friend ever.
He's so interactive.
Very interactive. Okay.
You guys are also the best.
Now, Clemmy and Srilakshmi, we had a talk while doing trials in the session where it was the first time that we talked so much freely, right? He was very cool, man. So you could also tell. Srilakshmi.
Yes, good evening to all. Actually, Rithish has done a very good job. In a younger age, he could do much more bigger thing than I did, and I didn't even know half of what he knew right now, even if I'm in 10th. So maybe because I'm not interested in computer science, or maybe nobody taught me, or maybe even I've never researched about it. And yeah, it was a good session, and we would like to know more feedbacks on how the session was today, the time management, the content from every one of you, so that we could improve more on our next sessions. So we would like to have feedbacks of Ritesh's session right now. I would like to welcome everyone, each of you, to open your mic and tell something which actually inspired you, or what you feel after the program. Yes, you could come up.
Megha, Rishikesh, come up, Brad. Tell something.
Look, here you're not going to actually ask any doubt, or no one is going to actually judge you. Actually encouraging someone and appreciating someone is much more bigger than what you do. So always don't even regret an opportunity where you have to encourage others or appreciate the good things they have done. It's actually one of the good quality in yourself. So appreciate, who have done a big thing. So don't even hesitate. Come on, open your mic and just appreciate Ritesh, what he has done in this younger age. And you could also do like this in the upcoming session of Rise Up, and that is what Rise Up is. So open your mic and encourage him, appreciate him for what he has done.
So I have one doubt. Why this microSD and this memory cards are not used in computers? There is not a slot for it in computers and laptops.
There are actually nowadays they give extra storage by giving SD cards and SD card slots in computers. So memory cards are being like they are also used, and even in mobiles they give, because for extra storage, because SSDs are expensive and HDD you can't use outside the computer. So they are providing my SD card slots nowadays in modern computers.
Well, Rithish Chatan, the class was amazing and I learned so many things from you.
Thank you.
How did you
Also,
come to know? Sorry. How did you come to know about GrainEd and you started attending the sessions, Rithish?
Ma'am, last year my sister was in 12th, so she got a link for GrainEd. And I also, I was in, so the session was mathematics. So I have a keen interest in mathematics. So even I wanted to attend the session and see what it was. That is how I joined GrainEd.
So Rithish, it was a nice presentation, and I learned more about the computer program execution. So thank you so much. And one thing I want to tell you all is that we can actually give feedbacks on the website on our session. So please do that. And for the next session, we are having a debate. So I hope all of you will participate in that. So thank you so much.